Hello, welcome to today's class. Today we have this challenge before us here. All right, so from the first one, we have x to the power of 3 minus x equals to 990. So how do we solve this challenge here? Now, in this challenge, I'm going to show you a trick to solving for all the three roots here, okay? Yeah, we're going to have one real root and we're going to have two imaginary roots. Now, in solving for the other two imaginary roots, I'm going to show you a trick of applying the quadratic formula, okay? So we can solve without the use of the formula here, okay? So I advise that you stay from beginning to the end of this challenge so that you get every details of whatever I'm going to teach in here, right? Okay, so here we have to solve for three roots, right? So let's take our solution here. So we have here solution. All right. Now, let's put down the question. We have the x to the power of 3 minus x here is equal to 990. So the first thing we're going to do here is to move the quantity we have on the left-hand side, right-hand side rather, to the left-hand side. So this is going to give us our x to the power of 3 minus our x, then minus 990 equal to this. Now, because we are having x to the power of 3 here, and here we're having x to the power of 1, we think of rewriting this quantity, which is 990, in such a way that we have a number that we raised to the power of 3, then add it to another number raised to the power of 1 to still give us this back. Okay, I will tell you the reason why we have to do it in this manner. And so this is going to give us here our x to the power of 3 minus our x, then minus 1000, okay, then plus our 10 equal to 0. So if you add or if you say minus 1000 plus our 10, that will give us 990, right? So we cannot go ahead and rewrite this 1000. And 1000 is 10 to the power of 3. So rewriting this is going to give us our x to the power of 3 minus our x minus 10 to the power of 3, then plus our 10 equal to our 0 here. This is simple, easy, right? Good. So we are having this s to the power of 3 here. We are having 10 to the power of 3. So we move this and this together. We bring this and this together. So this is going to give us our x to the power of 3, then minus 10 to the power of 3, then minus our x, then plus our 10 equal to 0 here. Okay. So what we do here now is this. We can put this in bracket and also put this in bracket. Remember, if we put this in bracket, then this sign will change. So let's go ahead and put them in bracket. So we're going to have s to the power of 3 minus 10 to the power of 3 close bracket, then minus bracket our x minus our 10 close bracket equal to 0. So yeah, the next we look at here, we are having x to the power of 3 and 10 to the power of 3. There's what we call the difference of two cubes, as we have the difference of two squares. So we equally have a difference of two cubes. And so difference of two cubes says that if you have your a to the power, this is a please, to the power of 3, then minus b to the power of 3, this is equal to bracket a, the plus this, good have this to be have here bracket our a, yeah, then minus our b close bracket a to the power of 2, then plus a b plus b to the power of 2 close bracket. This is what we call difference of two cubes. All right, so we go ahead to rewrite this in this format here. So this is going to give us bracket our x minus our 10 close bracket our x to the power of 2, then here plus our 10x, then plus our 10 to the power of 2 close bracket, then minus what we have in here now, which is bracket our x minus 10 close bracket equal to 0. So you discover we are having x minus 10 here, we are having x minus 10 here. So what we do, we just have to factor out x minus 10 from each quantity we have here, because we're considering the whole of this as a quantity on its own, and we are considering this as a quantity on its own. So we want to factor out x minus 10. So if we do that, this is going to give us bracket our x minus 10 close bracket, then bracket. Let's put this in a square bracket. Yeah, if you use this to divide everything here, we are left with this. So we're going to have here x to the power of 2 plus 10x plus, here we give us 100 rather, okay, then close bracket minus. If we use this to divide this, we'll be left with 1. So let's close our square bracket here. Okay, I want to believe we are learning something from today's class here. Okay, so the next thing we do here is this. We can go ahead to open up this expression we have here alongside with this one we have in here, right? So if we do that, so this is going to give our bracket our x minus 10 close bracket our x to the power of 2 plus our 10x then plus our 100 minus 1 close bracket equal to 0. So from here, let's look at something here now. Okay, now from here, we can carry out this operation here now, which is plus 100 minus 1. Plus 100 minus 1 will give us 99, right? Good. So this is going to give us our x minus our 10, then close bracket, then bracket our x to the power of 2 plus our 10x, right? Then plus our 99 close bracket equal to 0. There is what we call the zero property. Okay, which says that if you have your x times y equal to 0, then it either means that x is equals to 0 or y is equals to 0. Okay, I made use of that property in so many of my videos here. Okay, so if we consider that property, then we're going to equate this to 0, we're going to equate this to 0. And so we're going to have the first case scenario. So let's take this as our case 1. So our case 1, we have x minus 10 equal to 0. Move this to this side of the equation, right? So we're going to have this. Therefore, our x1 is equal to 10. So this is the value of our x1 that will satisfy the original equation. And if we have x to be 10, here we have 10 to the power of 3, that will give us 1000 minus 10 to the power of 1, which is 10. And 1000 minus our 10, that will give us 990. Okay, so we take the second case scenario. So we have here case 2, our case 2. What is our case 2? We are taking this as our case 2. So we have here x to the power of 2, then plus 10x plus 99, rather, this is equals to 0. Here comes this trick I said I'm going to teach you in solving a quadratic equation of this kind now. So how do you solve this? Now, we're going to check this out. You will discover that from here, the answer we're going to have is going to be imaginary root. So how do we do this now? We have to think of rewriting this 99 again with regards to this and this figure here. So I want to rewrite 99, or I think of a number that can add to this to get a number that is a perfect square to this, right? Good. So what perfect square, or will I go to add to this now to give me something like this? It is easy. So rewriting this expression here, this is going to give us x to the power of 2 plus 10x here plus our 99, then plus our 25, then minus our 25 equal to 0. We know that plus 25 minus 25, that will give us 0. So this expression is still the same thing as this. Now the question you might ask now is this. Why am I choosing 25? Because 25 is a perfect square. And again, you may ask, why 25 as a perfect square and not 4 or 16 or maybe 81 or 100? It is easy. The reason why I decided to pick 25 is because here is to the power of 2. And so that justifies the action of picking a perfect square. Then look at this. Here we are having 10. Okay? So if I rewrite this applying some algebraic identity, I want something that will give me 10 here. Do you get that? And so we have 2 times 5 will give us 10. And that is why I decide to pick this 25 here. So the next thing we do here is this. Move this one to join this one. Then move this one to join this very one here. So rewriting this expression, this is going to give us our x to the power of 2, then plus our 10x, then here We are bringing this 25 here now. So plus our 25, then plus, here we have 99, then minus 25 equal to 0. Easy. This is just the trick, okay? Just take time to absorb this. All right, so what we do next here now is this. We're going to consider this expression we have here now. Look at this expression from here to here. And we can equally subtract this easily, right? Good. So if we consider this expression, remember the algebraic identity which says that if you have your a to the power of, okay, let's just say a plus b all to the power of 2, this is equal to our a to the power of 2, then plus our 2ab plus b squared. You remember this? All right. So if you remember this, look at what we are having here. This expression is in this format. So I want to take it back to this format. So rewriting this expression in this format, what is it going to give us? That's going to give us x plus 5 all to the power of 2. So this is going to give us here, or this now implies that our x plus 5 all raised to the power of 2, then plus, look at what we are having here now. Here we are now having 99 minus 25. So if we subtract 5 from 9, that will give us 4, and 2 from 9 will give us 74. So here we have here 74, which is equal to 0. Now, mind you, this is a quadratic equation. So how do we solve this quadratic equation? It is very easy, right? Good. So if we share carefully, all we just have to do here, I want to evoke what is called the difference of 2 square into the system here. And for me to evoke the difference of 2 square here, it is easy. I just have to rewrite this 74 here now, okay? And also this sign, how to remanage this. So look at the manipulation I'm going to do here. So this is going to give us x plus our 5 close bracket, then minus the iota of the square root of 74, or in bracket, raised to the power of 2, this is equal to 0. This thing you have in here now is the same thing as plus 74. How do I mean? This square here will affect everything inside here. The square root of iota is equal to minus 1. Remember that from the square root of our minus 1 is equals to our iota. So if we decide to square both sides of this expression, so we're going to have this to the power of 2, this to the power of 2. And so this will go with this. So we are now having minus 1 is equal to our iota. Okay? That is I squared. All right? So minus 1 is equivalent to I squared. So if I use this to open this, this is going to give us minus 1. Then that minus times this minus that will give us plus here. And if I use this square to cancel out this square root, I will be left with 74. So we are having this expression in here equivalent to plus 74. So that is just the trick. And in this regard now, I can now evoke what is called the difference of 2 square. Look at here, we are having 2, oh sorry, this is 2 here, and here we are having 2 here. So evoking the difference of 2 square, what does it say? It says that if you have your a to the power of 2 minus b to the power of 2, right? This is equal to bracket between a plus b close bracket bracket a minus b close bracket. So the first one we look at is the difference of 2 cubes, and now we are looking at the difference of 2 square. So what we do here now, we just have to rewrite this expression. So we can rewrite this as our bracket open here, our x plus our 5, yeah, okay, close bracket. Then the first one here is going to give us plus. So we have here plus, here we have iota root 74. Okay, so we put this in bracket, then bracket, the second part is going to give us x plus 5 close bracket, then minus our iota root 74 close our square bracket, everything equal to 0. Wow, I will learn something here. Good. So again, we can apply the zero product rule, whereby we equate this to 0, we equate this to 0. And if we do that, what happens? We are going to look for our x here, okay? Because we can actually open up everything we have in here. And so from here, we're going to have our final answer to be in this format here. So we're going to have our x2. We've gotten our x1 already. So this is going to give us, this is positive. So when it crosses to this other side of the equation, this is going to give us our it's going to give us our minus 5, right? Then plus our iota root 74. This is 7, please. Let me write it where this is root 74. Okay? Then we're going to have our x3, which is equals to, we're still going to have it to be minus again, because here we have plus sign. So it, when it crosses to the other side, it's still going to give us minus. So here we're going to have minus 5 here, then minus our iota root 74. All right, so these are the other two roots to this challenge. Mind you, we'll solve for our x1 here already. So our x1 is this, and our x2 is an imaginary root. Then our x3 is also an imaginary root. All right, so this brings us to the end of this math class. If you learned something from this video tutorial, do not forget to give the video a thumbs up. Remember, this is Online Maths TV, and my name is Jakes. I love you dearly. Keep watching Online Maths TV. Drop a comment in the comment section. I'm going to meet with you there. Bye. But until we see you in our next class, keep winning.